The IPCC's most optimistic scenario predicts CO2 levels will reach over 550 parts per million by the time the world achieves carbon neutrality, well above the 350 ppm threshold for preventing runaway climate change. We will need to remove over 1.6 trillion tons of CO2 from the atmosphere to ensure the stability of our climate. Theoretically, it should take 96 kilowatt hours, or less than $10 at 10 cents per kilowatt hour, to capture a ton of CO2. But the low concentration of atmospheric CO2 requires high capital costs to process enormous volumes of air at efficiencies as low as 2%. This means direct air capture schemes cost well over $600 per ton of CO2. Xerox recently proved it's possible to capture CO2 from seawater, where it's over 140 times more concentrated than in air. This significantly lowers capital cost and requires only 1,200 kilowatt hours, or $120 per ton of CO2. We plan to significantly lower the cost of capturing CO2 by building on Xerox's work, then offsetting the remaining cost by realizing value in the carbon we plan to collect. Xerox's system uses electrodialysis to separate seawater into acidic and basic streams. The acidic stream reduces the solubility of CO2, which is desorbed in a vacuum. The two streams are then recombined into regular seawater. Our design recaptures up to 85% of the input energy by adding a reverse electrodialysis system where the acidic and basic streams are recombined, reducing the cost to $24 per ton of captured CO2. Once we've demonstrated improved carbon capture efficiency, we'll add an electrolysis system to generate hydrogen, which can be combined with CO2 to form syngas, an energy-rich feedstock that can be processed into many other hydrocarbons, including plastics, industrial chemicals, and drop-in replacements for fossil fuels called synfuels. Most of the syngas we produce will be converted to methanol, a liquid feedstock that is almost as versatile as syngas, but much easier to store and distribute. The CO2 capture system and the electrolysis system will be driven by renewable energy sources, which effectively use methanol as a battery. Hydrocarbon synthesis allows us to seamlessly integrate renewable energy sources into existing fossil fuel infrastructure and potentially turn carbon sources into sinks when fitted with carbon capture technology. It separates the energy supply from the time and place of consumption, mitigating problems of intermittency plaguing most renewables. It's imperative that we reduce CO2 levels, and we at Helionautics believe our technology can provide the most cost-effective means of achieving this goal.